All right, so the first two questions I'm going to pull off of Math Lab. All right, y'all. So I'll let y'all sort of answer some of these as we're going through here. So this number one wants us to know which of these four sketches describes the end behavior of this function. So two things, we made a chart on this. We had the degree was either even or odd, and the lead coefficient was negative or positive. So this has a degree 6, which is even, a negative pi, which is a negative lead coefficient. So y'all, when it was even with a negative lead coefficient, you would pick choice B because both ends will go down, okay? So remember, these are the four sketches that you had to choose out of. Now, number two will be the same type of problem here. But notice, number two is out of order. So find the degree, which is that the degree is a 7, because that's the highest exponent in this polynomial. 0.7 is positive, so we got an odd degree with a positive lead coefficient. That one would go uphill left to right, so we would pick D on that one. All right, y'all. So the next few I'm going to actually work on paper for us. So for number 3 on the study guide, they want us to find the zeros. And the multiplicity. All right, so for this one, they're giving us f of x equals x squared minus 9 to the 5th power. All right, so we will know that the 5, that exponent sitting outside those parentheses, that 5 is our multiplicity. So to find the zeros, we got to take that factor, x squared minus 9, and set it equal to 0. So for this one, the quickest way to solve that for the x's would be to add 9 and do the square roots. So I get x squared equals a positive 9. Then I'm going to square root both sides. So notice square root of x squared gives me x. Since I'm taking the square root of a number, I got to use my plus or minus, and then the square root of 9 is 3. So that gives me a plus or minus 3. So my zeros will be a plus or minus 3. Each has a multiplicity 5 because that's the exponent on the outside. And also, that is the trick on these, is to take the factors, set them equal to 0, and remember that those exponents on the outside of those parentheses is giving us the multiplicity. All right, number 4 is the same thing. Find the zeros and the multiplicity of each. All right, so this time they gave me f of x equals -2 times x minus 2 to the 4th, x plus 5 to the 3rd, and then x to the 3rd. So this one will be set up. The 0, 2 has multiplicity blank. Blank is a 0 of multiplicity 2. And then they'll have the remaining 0 is blank. It has multiplicity blank. So these were the answer blanks for this one. So the first thing I would do would probably find the zeros. Now, this -2 out front, it does not have a variable with it. So since that -2 does not have a variable, cancel it out because it is not a factor we're concerned about. The only factors we're concerned about are the x's. So I'm going to take x minus 2 set equal to 0, x plus 5 set equal to 0, and then the x at the end, I'll set equal to 0. So remember, single variables always have a 0 of 0. So we need to find these other two. So y'all, the first one, we're going to add 2 to both sides. So my first 0 is a 2 from that factor, x minus 2. My second 0 is going to be a -5 from the factor x plus 5. So remember, the factors and the zeros always have opposite signs. So we got our zeros. So here it wants to know the 0, 2 has a multiplicity blank. So I'm gonna let y'all answer. What y'all think? The 0, 2 has a multiplicity of. So definitely a 4 because it came from that factor. So the 0, 2 has a multiplicity of 4. So then y'all, blank is a 0 of multiplicity 2. Oh, so what are y'all putting here? Blank is a 0 of multiplicity 2. Oh, hang on, y'all. Hang on. I wrote that problem wrong, I think. This should be a 2 right here. My bad. So the x plus 5 has a 2 by it. I wrote a 3 by mistake, but I was looking at the problem, and that's actually a 2 right there for that exponent. So change that. So now you can fill this in. Blank is a 0 of multiplicity 2. So that's going to be the. Now don't put 5 on that. Remember, what was the actual 0? -5. Good job. So then it says, hey, the remaining 0 is blank. It has multiplicity blank. So 0 and 3, let's see. So 0 is the 0 and it had a multiplicity of 3. So remember, the multiplicities are the exponents and the zeros are those solutions. All right, y'all. So same thing for 5. Find the zeros and their multiplicities. All right, they're giving us f of x equals x to the third minus 3x squared minus x plus 3. So this is probably the trickiest one where you had to find zeros, because this was a 4-term polynomial. And to solve it, we had to do that factor by grouping. So I'm going to do factor by grouping this into 2 sets of terms. Now, out of each of these sets, you had to factor out the greatest common factor from each pair. So y'all, the first one has the x3 minus 3x squared. The greatest common factor for the first 2 terms was the x squared. So you would break out the x squared and put in the parentheses what you get when you just divide both of these by the x squared. So the x to the third divided by x squared leaves an x. The 3x squared divided by the x squared leaves a -3. Second GCF has to have a sign in front of it, and it is always the same sign as that third term. So since it was negative, my GCF would be negative. And y'all, the only thing common for an x and a 3 would be a 1. So the second GCF, we're factoring out a -1. So we divide both of these by -1 and put those answers in here. So negative divided by negative makes that a positive x. Positive 3 divided by the -1 makes that a -3. And y'all remember at this point, parentheses must have the same stuff in both of them. So if you don't have an x minus 3 in both parentheses, you got to go back up here and fix those GCFs, okay? Because now my next step, remember at this point, we took the stuff on the outside, the x squared and the -1, and we put them in one parentheses. So the x squared minus 1 goes in one parentheses. The x minus 3 goes in the second parentheses. So the outside makes one parentheses, and then the stuff that matches in the inside makes the second. Because look, x squared times x squared times -3, that gives you this, and then the -1 times x, -1 times -3. So you're just rewriting it. We're not changing it, okay? So this is now factored. So remember, to find the zeros, I'm going to take both of these and set them equal to 0. So since that's x squared minus 1 equals 0, I'm going to solve it once again by doing the square roots. So the square root of x squared will equal the square root of 1, which means x will equal a plus or minus 1. For the second one, that's just the x minus 3. So I'm just going to add 3 to both sides and get x equals a +3. So my zeros, now remember, that was the x to the third. So a degree 3 has to have 3 zeros. So my zeros will be 1, -1, +3. Each has a multiplicity of, so y'all, here's the question. What are these multiplicities on these zeros? Oh, good job, Karen, because remember, since I don't have exponents on these parentheses, we would treat both of these like they had a 1 on those parentheses. So each of those will have a multiplicity of 1. All right, 6 is a true or false. So if p of x equals x minus 4 to the 8th times x plus 3 to the fifth, the graph crosses the x-axis at the point 4, 0. So is that true or false? And y'all, what you got to look at on this, since they're talking about 4, 0, 4 would be the 0 on that x-intercept. The only factor that would come out of has to be the x minus 4 to the 8. Also, let me see what we got. We got a false on the board, so let's see. So since it has to come out of this factor, in the 8 is an even exponent. Since it's an even exponent, it would actually be tangent to the x-axis and not cross over. So good job. This is definitely false. Remember, even degrees are tangent to odd degrees crossover. Now, had they said -3, 0, and it crossed over, I'd have said true because that would have been an odd degree. So the odd degree crosses over, the even degree comes down and touches it and sort of tangent. All right, so we're giving you a function, f of x equals -6x minus x to the 7th. On this one, they want to know the maximum real zeros, the maximum x-intercepts, and then the maximum turning points. All right, so this can go pretty quick if you remember this. The maximum real zeros and the maximum x-intercepts, they're basically the same thing. So whatever you get for the real zeros, you better get for those x-intercepts. And y'all remember, the maximum real zeros is equal to the degree of that polynomial. So I've got a degree 7 polynomial. That means my maximum real zeros is 7. My maximum x-intercepts is 7. The maximum turning points was always the degree minus 1. So since my degree is 7, when I subtract 1 from that, I will have 6. Okay. All right, y'all. So number 8, I'm going to show y'all how to set your window on your calculator so you can match these pictures up perfectly. So let me go to the math lab for this one. So I said this was number 8. Y'all are giving me a polynomial, x times x minus 4 plus x plus 5 times x minus 8. So if we want to get a picture that looks exactly like theirs, and I'm going to zoom them up a little bit, we're going to set our calculators to these windows they got. So let me write down my polynomial. X times x minus 4 times x plus 5 times x minus 8. So I got the problem. So notice this goes from negative 10 to 10 on the x's. But then it goes from negative 100 to 100 on the y's. So if you set that window on the calculator to match these, we'll get exactly one of these four pictures. So let's go to my calculator and I'm going to remind y'all how to do that. So to set the window, you got a button that says window up here. So first let's put in our equation. So I had an x times x minus 4 times x plus 5 times x minus 8. So I got my function in there. I'm now going to set the window. So click the window button. So the x's look good. The x minimum is negative 10 like it needed. The x max is 10. So what I got to do is play with the y values. I'm going to arrow down to my y minimum was negative 100 on that graph. So I'm going to put in a negative 100. My y max was a positive 100. So all you really got to do is come in here and change your x's and y's if you need to. And y'all, let's graph this. So notice it basically looked like a W going through there. It came down, went up, down, and up. So let's go look on MATLAB, which one sort of matches that. So I'm just going to make them a little larger for you real quick. And y'all, looks like C was it. It came down, went up, down, and up again. So I would pick C on that because it matches my graph. And then move on, okay? Now, if you want to do that one by hand, you can get the basic idea of where it's crossing at. But that's a lot of work. All y'all got them calculators, so I probably just use my calculator and move on that. And now look, 9 is the same way. Now look on here. So this is an odd degree of 3, and the 9 is positive. So anytime the degree was odd and the leading coefficient was positive, it went uphill left to right. But y'all look at this, B and C match. So what I would probably do is go graph this on my calculator. And I'll show you another trick on this one. Since that's got a 54 at the end, that is the y-intercept on it. So between B or C, you would have to figure out which one's crossing the y-axis at about 54. And it looks like since that's 250, these are going by 50s per mark. So B is pretty close to the 50. Over here on C, that was going right through the center. So I would probably pick B because of that 54. But y'all, let's graph it and see. So for that one, I had 9x to the cube minus 6x squared minus 81x plus 54. Now remember my window on that one, if you remember the window, went from negative 5 to 5 on the x's. The y values went from negative 250 to a positive 250. So if we want our graph to match what they're giving us, change that window. Then when we hit graph, you can see the center is not coming through the center of the graph. It's a little bit higher. So y'all remember your picture when you come back to the math lab. And I would definitely go with B on that one because remember, It didn't go through the center like C, it was a little higher. So for this one, you're probably going to pick the picture between the two that look the same. But look at that y-intercept, which is what that 54 is, okay? So y'all, those two I would probably definitely set my windows. All righty, so number 10, we get to start doing synthetic division. So using synthetic division, we're going to determine if the numbers are zeros. All right, so they gave me a -1 and a 1, and then a semicolon, and my function is h of x equals x to the 4th plus 3x to the 3rd plus 2x squared minus 6x minus 6. So they're giving me the two zeros. They're going to be -1 and 1, and I got to try them in this polynomial. So let me start with -1. And y'all, the answers got to go in the same order as they're giving us. So figure out whether -1's a 0 first, and then the 1, because this will be a yes, 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 no, no, yes type questions, okay? So I'm going to try -1, and here's my coefficients: 1, 3, 2, -6, and then -6. If that's going to be a 0, then that remainder better be 0 for these, okay? So yes, if I get a 0, no, if anything else. So bring the 1 down. 1 times -1 is -1. 3 plus -1 is 2. 2 times -1 is -2. Well, 2 and -2 give me 0. 0 times -1 is 0. -6 plus 0 is -6. And then -6 times -1 makes that a +6. -6 plus 6 and give me 0. So -1 is a 0, you would put yes. And then we would check a +1. So we got the same numbers: 1, 3, 2, -6, -6. So if 1's a 0, I better get a 0 remainder. So here we go. Bring the 1 down. 1 times 1 is 1. 3 plus 1 is 4. 4 times 1 is 4. 2 plus 4 is 6. 6 times 1 is 6. -6 plus 6 is 0. 0 times 1 is 0. So now -6 plus 0 give me a -6 remainder. So that would be no for 1. So trick, just take your two numbers and run them through synthetic division, looking for a 0 remainder on those, okay? All right, y'all, let's see what they got coming up. So number 11, find a polynomial degree 4 with -4, a 0, of multiplicity 3 and 0, a 0 of multiplicity 1. So remember, the multiplicity tells you how many times that 0 happens. So the first 0 is -4, and it happens 3 times. So that'll be x equals -4, x equals -4, x equals -4. So that was 3 times. And then 0 is a 0 of multiplicity 1. So that means the 0 happens 1 time. And y'all, anytime I got zeros, I sort of put them in the front. So I'm going to put my 0 of 0 in the front, because that's the easiest one when you want to FOIL the other stuff first and then take that x and sort of run it through when you distribute it. So remember, these 3 will be put in parentheses. This one, I don't have to solve it, so that x is going to come straight to the front. Now, the factors always have opposite signs than the zeros. So since all those are negative, my factors will be all positive. So when you factor it, change the signs, put them in parentheses. And y'all, guess what? I'm going to start foiling. So I'm going to FOIL these 2 first. So I'm going to FOIL that on the side. X plus 4 times x plus 4. So x times x will give us an x squared. That x times 4 will give us a 4x. Then we do the 4 times x and get a 4x. And then 4 times 4 gives me 16. So the only other thing I'm going to do is add the like terms. So I get an x squared. 4 plus 4 gives me 8x plus my 16. So let me bring down that x and that x plus 4. And from FOILing, that gave me an x squared plus 8x plus 16. So next, I would FOIL this stuff right there. So I'm going to do that on the side. I'm going to take a x plus 4 times x squared plus 8x plus 16. So this first x will come down, and whatever this gives me, I'll put into parentheses. So you now have to distribute the x times all 3 of these, then come back and get the 4 and multiply by all 3 of these. So x times x squared is an x to the 3rd. X times 8x is an 8x squared. X times 16 is a 16x. Now do the 4. 4 times x squared is a 4x squared. 4 times 8x is 32x. And then 4 times 16 is 64. So I would actually definitely add my like terms before I put it over here. So you got an x to the 3rd. 8x squared plus 4x squared to give me 12x squared. I got 16x's plus 32x's. Ooh, let's see, 16 and 32 will be 48x's. And y'all, at the end is my plus 64. So this will now go into these parentheses. So remember, I got to end up with a degree 4. Right now I'm at a degree 3, but guess what? I'm about to multiply everybody inside the parentheses by that x. So we're basically distributing that last x through. So x times x third is an x4. X times 12x squared is a 12x cubed. X times 48x is a 48x squared. And then finally, the x times 64 is a positive 64x. So now we have our degree 4 polynomial. So the trick on this one, set up all your factors, and anytime you got 0 as a 0, that's just going to come down as an x. Now, if this would have been a 0 as a 0 multiplicity 2, I'd have brought this down as an x squared and just waited till the end and distributed it, okay? So check out this one. Suppose polynomial degree 4 has zeros of I and 4 minus square root of 5. What are the other zeros? So if I got a degree 4 polynomial and some of my zeros are I and 4 minus square root of 5, and that's a degree 4, I need 2 more zeros. So what are my other 2 zeros? Do y'all remember how to do this one? So it looks like a negative I. So the negative I is perfect. So negative I is one of them. So you just change the sign on the I, that gives me a negative, and then I get what? 4 plus square root of 5, perfect. So change the sign on the I, make it negative, and since this radical here was negative, you write it with the radical being positive. So good job, because you didn't change the sign of the 4, only the radical part. And y'all, yours are going to be really, really similar. I've seen them use I every time. And then the only thing I've seen them change on the actual test is the numbers on the radicals, okay? All righty, so you had to know that so that you could do number 13 here. So let me get my paper ready. So find a polynomial lowest degree. With some of the zeros being a square root of 3 and 5i. So this is the one where we have to FOIL again. And they're not telling me what the degree is because they don't want to give away how many zeros this one has. But y'all tell me this. If square root of 3 is a 0, then that means negative square root of 3 is also a 0. If 5i is a 0, then negative 5i. So this means negative square root of 3 and negative 5i are also zeros. So I got to write out my 4 zeros. X equals square root of 3. And I'm going to put the radicals by each other. So square root of 3, negative square root of 3. Then I'll put my imaginary stuff by each other. So if they give you a radical, it's opposite. If they give you an imaginary, it's opposite. So 4 zeros. So I'm going to need 4 sets of parentheses. Because when they want you to find a polynomial, that's where you're doing all that FOILing, okay? So change the signs of these. So this will be x minus square root of 3, x plus square root of 3. That'll be x minus 5i. This one will be x plus 5i. So always change the signs of the zeros when you put them into factors. Now I did this because these are conjugate pairs here when I FOIL. These two are also conjugate pairs when I FOIL. So since these are conjugate pairs, I can do the shortcut FOIL. Same thing here. These are conjugate pairs. So I'm going to do the shortcut FOIL. So remember, shortcut FOIL, these two will end up in a parentheses. These two will end up in a parentheses. Shortcut FOIL, x times x is an x squared. A negative square root of 3 times a positive square root of 3 would be a negative square root of 9. So stuff under a radical multiplies and stays under the radical. Now we're going to fix that in a second because we know what the square root of 9 is. Now over here, I'm going to shortcut. X times x is an x squared. Negative 5i times a positive 5i is a negative 25i squared. Do y'all remember what I squared equals? -1. Good job. So we're going to do two things on this. We know what x squared. This one will give me x squared minus square root of 9 is 3. The second one, well, that -1 being in place of that I squared is like a negative times a negative. So that's going to make that one a positive 25. So y'all remember this. Radicals always end up negative in the middle. The imaginary stuff always ends up positive in the middle. Okay? And then you could have shortcutted this even further. Square root of 3 times square root of 3 would have just been a 3 in the long run. So just remember, a radical times itself gives you that number in the long run, okay? All right, so let's finish out. X squared times x squared is x to the 4th. X squared times 25 is 25x squared. -3 times x squared is a -3x squared. -3 times 25 is a -75. Add the like terms. So x4, 25 minus 3, what's that leave me? 22x squared. Bring down your 75. So remember, I had 4 zeros. I had to end up with a degree 4. All right, so that's the reason they do number 12 with you, so that you realize when you're doing this that you have to have these conjugates when they give you these type of zeros, okay? So 14, they're giving us the polynomial has the given 0, find the others. So the polynomial has the given 0. Then it says find the other zeros. So they're saying f of x equals x to the 3rd plus 8x squared minus 2x minus 16. And then they got the semicolon, and the 0 they're giving me is -8. So since this is degree 3, we're going to do synthetic division with this 0 they're giving me. And then I could use the quad formula or another method to solve for the other two. So we're going to start out with that -8. Let's see, my coefficients are 1, 8, -2, -16. So nothing was missing. My x3, x2, x, and my number. So since they're telling me -8 was a 0, we got to get a 0 remainder here. And then these three numbers we get, we can do another method to get the last two. So y'all bring down to 1. 1 times -8 is -8. 8 and -8 equals 0. 0 times -8 is 0. -2 plus 0 is -2. -2 times -8 is a positive 16, which gives me 0 remainder. So remember, these would be like an x squared. So 1x squared, that's like a 0x in the middle, minus 2. So these are always the coefficients of the new polynomial. And remember, since this one was an x3, this one starts 1 less. But y'all, this is like x squared minus 2 equals 0, because 0x is gone. Now, if you're doing quad on the calculator, A is 1, B is 0, C is -2. If you're doing quad by hand, there's your A, B, C. But y'all, these ones are quicker. If the middle number is 0, on these, I just add the number to both sides. So I get x squared is 2, and then I take square roots. So the x is a plus or minus. Woo, we can't do nothing with that. So that'd just be what? A plus or minus square root of 2. So this one would say the other zeros would be a square root of 2 and a negative square root of 2. Now, I do believe MathLab will let you use the plus or minus on these, okay? All right, 15 says find the domain of the function. So they're giving us f of x equals x to the third minus an x squared plus an x plus 2 all over x squared plus 8x plus 12. All right, so this one, since it's domain, we're only worried about the denominator. So take your denominator and set it equal to 0. Now, if you want a quad formula, 1, 8, 12 on the quad would work. I'm just going to factor it real quick. X squared is an x and an x. The last number is positive, so both of these will be positive like the middle number. So y'all, what we need now is factors of 12 that'll add to give me a 8. All right, what am I seeing? 6 and 2, perfect. So now that's the factors. So remember, now we got to get the signs changed. So subtract 6. So I get x is a -6. This one will subtract 2 and get x is a -2. So they wanted the answers in set builder and in interval notation. And y'all, they want them in ascending order. So you got to go from left to right, smaller number to the larger. So the set builder would be x such that x is a real number and x cannot equal. So let's see, going left to right, I would have a -6, comma, -2. So these got to be in ascending order. Interval notation, And I think the reason they wanted these in ascending order was be so you get the interval right. Because you're going to go from -infinity to -6 first. From -6, you would go until you hit that -2, union around that -2 until you get to +infinity. So make sure both of these are in order from left to right on these numbers, okay? All right, y'all, let's see what we got next. 16, find the domain. So it looks like two domains in a row. So this one was f of x equals 1 over x squared plus 2x minus 24. So you can hit this with the quad also. I'm just going to factor it real quick. So x and an x. Last one's negative, so I'm going to have unlike signs on this. So y'all, what factors of 24 will subtract and give me a 2? Okay, 6 and 4, and then remember the larger number has the same sign as the middle. So we'll make the 6 positive and the 4 negative. All right, so setting these equal to 0. I get a -6. This one will give us a +4. Now 16 only wanted the answer in interval notation. So that'll be from -infinity. Let's see, we'll hit the -6 first. Union -6 till we hit the 4. And then union from the 4 till we hit positive infinity. No, I'm gonna put it here. All right, 17, determine the vertical asymptote. G of x equals x to the third over 3x to the third minus x squared minus 52x. So remember, to find vertical asymptotes, you take the bottom, set it equal to 0. So you can't factor this yet because you got x3s up here and you got too many x's. So the first thing you want to do is factor out an x on this. So factor out the GCF of x. So then take away 1x and put that answer into parentheses. So that'll give you 3x squared minus 1x minus 52 now equal to our 0. All right, so at that point, I'm probably just going to hit this with the quad. So I know this x is coming down. All right, y'all. So I'm going to do what I'm going to do here. I don't remember if I showed y'all how to factor with a number in front. Did I show y'all how to factor when I had a number in front? Y'all remember? Okay, so we're just gonna do this on the calculator then. So we won't worry about factoring it. We'll just use the quad to get our two answers. So I know this one gives me x equals 0. The quad will give me the two answers that I would have got here. So let's go to program quad. So I have a 3 enter, -1 enter, and a -52. So when we hit enter, now notice I don't want decimal answers, so I hit enter one more time. So that gives me x equals 13 thirds and -4. All right, so check this out. These are the three numbers that would make this undefined, but y'all remember, on top is an x to the third. X to the third is like an x times the x times the x. So remember, if you got a factor on bottom, which is this x, that matches a factor on top, which is an x, those factors would cancel out, which means you cancel out that asymptote. This is the one that would make a hole in the graph. So remember, the factor with the zero, with the zero cancels out this vertical asymptote, which means you only got two. So your answer would be x equals 13 thirds, comma, x equals -4. Now think on this one, they'll give you the x equals part. I think the math lab will give you this. So you just got to put in your two numbers with a comma. So yeah, since we didn't do that factoring in here with the numbers, we'll just want to use quad and get the other two answers. Y'all, your number 17 will be exactly like my 17. Your factor that gave you the 0 is going to cancel out with the top, because your top will probably be an x3 just like mine, okay? So it's definitely going to cancel out. All right, 18 says determine the horizontal asymptote. So they're giving me f of x equals x squared minus 5 over 2x to the 4th plus 7. So horizontal asymptotes looked at the degree. So the degree on top is a 2. The degree on bottom is a 4. So the bottom degree is greater than the top degree. So anytime the bottom has a higher degree than the top, the horizontal asymptote would be y equals. So what y'all think? Remember when it was bottom heavy, they always had the same asymptote. Oh, good job. It would definitely be y equals 0. Now, if the top was bigger than the bottom on the degree, we would say no horizontal asymptote. And then if they were equal degrees, we looked at the numbers in the front. That was at A over B. All right, solve the inequality. They're giving me x minus 1 times x plus 3 has to be less than 0. So this is where I did the testing points. So this one's already factored. So I've just got to set these equal to 0 and solve this. And remember, since I'm solving it now, my answers will have opposite signs than it did inside the parentheses. Because y'all, that's all we're doing when we do this part. We're just changing the signs. So here's a -3, x equals -3. Then I set up a number line with my two answers, -3 there and 1 there. And to actually see where I shade, I'm going to test 0 in this. Remember, if it's true, I shade the middle only. If it's false for 0, I only shade the outside edges. So let's put a 0 in for these x's. So 0 minus 1 is -1. 0 plus 3 is 3. So y'all, that's going to give me a -3 less than 0, which is actually true for this one. So since that's true, that means I shade where 0 was located, which is in between the -3 and the 1. So since it's true, shade where 0 located. All right, so we can't, they want to answer in interval notation. So the only interval will be this center interval. It's going to start at -3 and end at the 1. So would y'all use curly parentheses or brackets on this one? Okay, looks like curly parentheses. So yeah, curly parentheses at 3, go to 1, close those parentheses and be done. So you only want to have the part that's shaded in that interval. All right, y'all, same thing. We're going to solve this one. X squared plus 17 has to be less than 6x. So when you start this one, the trick is you need a 0 over here. So your first step, you need to move the 6 over to the other side by subtracting. So I'll have an x squared minus 6x plus 17 has to be less than 0. So now I'm going to try to factor it and set it equal to 0 so I can get those two numbers. Last one's positive, so both factors will be negative like the middle. Oh, y'all, I need factors of 17. That'll give me a 6. So this one's not factorable. Good job. So factors of 17 is 17 and 1, and that's not adding to a 6. So remember, if it's not factorable in the math lab for no solution, you got to use the circle with the line through it. So that's what we use for no solution. All right, y'all. So that are the 20 questions you want to know for our test. So play with your study guide. It's going to be the same 20 as your test. They're just going to change the numbers up on you a little bit. So play with that study guide. Also remember, I sent a bonus for test 3 out to your email earlier today. So you'll get 2 emails from me today, one for the bonus and then one for this study guide, okay? All right, so not a whole lot of work this week other than you got your test, and we'll do 9-3 next class. But it's not too bad. So the test due, it's due this Sunday, but if y'all have issues, I'll probably extend it another week. Okay. All righty, y'all. So let's see. Any questions? All right, so what we'll do Wednesday, we'll come in, do 9.3. That's it for the week. That way y'all can concentrate on your test. What that say? Need support. Okay, so give me a homework question, Claire. And I probably got copies of them, so I can pull up the math lab. Let me pull my math lab up.
Basically, I'm stumped on, it's one of the factoring questions, but it was using only variables. And it was, I guess, the order of factoring out the variables that was kind of getting me. I'm trying to get
So
to
was
the
it
exact.
actually was it the support homework though?
It might be. Hang on.
All right, so let me find where I think we were doing the factoring at. Let's see. Because some of the support was a little crazy in the beginning. All right, so not that one. Let's see, support. So 8.4 was mostly foiling and getting all ready for that. So let me find. Probably 8.5. Let me get into that. So the 5.1, it's got to be 8.5. Let me pull that up. That's 20.
Now I'm struggling to find
That's
it.
what I'm trying to go
Find
through here. How about I'm gonna go to the grade book and pull you up
Yeah, sorry.
and see
I
what
got stuck on that one and
they
it,
usually got two grades on them. Okay,
mhm.
so the only one that I got a 0 really for you on is 5.1.
Okay. I think that might have been it.
Oh,
Let's see. Was it 5?
okay, this looks like factoring. So let me share the screen so you can actually see what I'm on.
Okay.
So share screen. So are you seeing it now? It's a 12s squared plus a 4s.
Mm-hmm.
And would that be the section?
It's that section, but the particular question I was stuck on had only variables. And I'm struggling.
Okay, so let me. So this one's got an x4 and a 5x3.
Yeah, it had no numbers. It was just
So they're probably changing them up since I'm going into your area. Let's see.
Might-
Well, these seem to have, these are all sort of throwing variables at us.
I think it was one of the chapter 8 ones.
Okay, so let me pull back through your stuff.
Let's see. I'm looking as well.
Oh, yeah, that's true. Let's see what this one is. This one has 2 or 3. Oh, them just synthetic division now, so not that one.
How about I send you an email once I come across it?
Okay, yeah.
Work.
Look at,
Sorry, I was a little unprepared on that one. I was just like, wait a second. I got stuck there. Let's see.
if they'll just leave them at this, God, I remember those, but I can't remember where they're at. So, all right, let me just. So you're saying it was doing the factor out the GCF stuff, but you had a lot of variables.
It was all variables. So I could find the first and last terms okay, but I struggled kind of in the middle, having, say F square, R square, or which one came first, or I don't know if that makes sense. Hang on. Oh, I wish I could find it. It would be so much easier.
Oh, I got one more place. Let me go one more place.
Maybe this.
All righty, so yeah, do that then, because I'm not able to, I'm not seeing one like a.
Okay, no problem. Can I also just hit that tab where it says ask instructor? Would
Mhm,
that be
mhm,
okay? Great.
mhm.
I'll do that then.
Yeah,
Thank you for trying to help me find it.
yeah, because it might be one of the multi-step ones where you got to factor out the GCF and then factor what's left,
Uh-huh.
like a trinomial or something. So if you just click that, I'll hit that right back to you, okay?
Okay, sounds good. Thank you so much.
All right.
Okay, have a good one.
All right.
Happy Halloween.
Oh,
All
yeah,
right.
that's right, ain't it? So y'all go have
Okay,
fun and have Halloween, and I will see y'all Wednesday.
sounds good. All right, take care.
All right, you too.